নমস্কাৰ CMST অৰ্থাৎ Commercial Mathematics and Statistics ক্লাছৰ আমি আজি আকৌ লগ হৈছোহি আৰু আমি যোৱাকালি মধ্যমাৰ বিষয়ে পঢ়িছিলো that is we had started and taught and learned what median is and today we shall continue with median আমি মধ্যমাৰ আজি যিখিনি বাকি আছে আমি হেখিনি আকৌ আৰম্ভ কৰিম In yesterday's class, we had talked about median, its definition, along with the various formula that we use for calculating median in case of a discrete frequency distribution, in a discrete non-frequency distribution, and also we had discussed about the formula used for calculating median in case of a grouped frequency distribution. Today, we shall learn about the graphical representation of median. As you all know, that median is a measure of location. That is, it can be found or median can be calculated or located with the help of a graph. So, we shall go to the graphical representation of median. অর্থাৎ লেখৰ সহায়ত কিদৰে আমি মধ্যমা মূল্যাঙ্কন কৰি উলিয়াব পাৰো তাৰ বিষয়ে আমি আজি পঢ়িম So today's topic is graphical representation of median লেখৰ সহায়ত মধ্যমা নিৰূপণ কৰা পদ্ধতি So in your higher secondary first year class, you had learned about the different graphical representations. Today, we are going to go back to one of those while studying this topic. I think you remember what an Ogive is. Yes? What is an Ogive? Ogive is the cumulative frequency distribution curve. Cumulative frequency curve. Yes, there are two types of Ogive as you already know, and I think you can brush little bit what you have already learned. Ogives are of two types. One is the less than type Ogive, and the other is the more than type Ogive. All right. For drawing the less than type Ogive, we make use of the less than type cumulative frequency, and for drawing the more than type Ogive, we make use of the more than type cumulative frequency. So, for graphical representation of median or to find the value of median, we have to make use of the Ogives. Ogives are very conveniently used for graphical representation of median. So, both the Ogives, that is the less than type as well as the more than type Ogive, can help us to locate median graphically. Let us see how. So I think you know how to draw an Ogive. Yes? So if we want to draw the less than type Ogive, on the x-axis, we shall plot the upper class limits. On the y-axis, we have the less than type cumulative frequencies. And when you plot the points from your distribution, you get a curve of this shape which is called the less than type Ogive. Similarly, to draw the more than type Ogive, on the x-axis we shall plot the lower class limits and on the y-axis we have the more than type cumulative frequencies. And when points are plotted from the given distribution, we shall get the more than type cumulative frequency curve, which looks somewhat like this. Now, for finding median, what we do is we shall calculate n by 2. You remember what is n? N is the total frequency. We shall calculate the numerical value of n by 2 and plot it in the y-axis. Supposing this point is n by 2. Alright, from this point, supposing this is point P. Alright, from the point P, which corresponds to the value n by 2, we draw a line parallel to the x-axis which meets the less than type ogive at some point, say Q. Alright, that is, we are drawing PQ parallel to the x-axis. Alright, from the point Q we drop a perpendicular, say QM. We drop a perpendicular, that is QM perpendicular to OX is drawn such that the point M lies on the x-axis. Then this point M will have a x coordinate as well as a y coordinate. Yes, since it lies on the x-axis, the y coordinate will be 0. So this is x0. Now the numerical value of x will give us the, so x, the coordinate x will give us the median of the given distribution. Yes, similarly, if we make use of the more than type ogive, same procedure is followed. We locate the point corresponding to n by 2 on the y-axis. We name it as point P. From point P, we draw a line parallel to the x-axis which meets the ogive at some point Q. From the point Q, we drop a perpendicular, say QM, such that M lies on the x-axis and then the x coordinate of the point M is the required median for the given distribution. So in your exam, either you make use of the less than type or you make use of the more than type ogive if you're asked to find median graphically. Either of them will give you the same result. Again, sometimes it might be such that you can find the numerical value of median from the point of intersection of the two ogives also. If we draw both the ogives together on the same xy plane, you have the upper class as well as the lower class limits. আমি x axisত upper class limit, lower class limit দুটাই লম. y axisত আমাৰ cumulative frequency বোৰ থাকিব আৰু আমি less than type ogive as well as more than type ogive আমি এবাৰ একেলগে আঁকিছো. আঁকিলে a point of intersections of both the curves. From there, if we drop a perpendicular, say QM, on the x-axis, then the x coordinate of M is the required median. And if we drop a perpendicular from this point Q on the y-axis, say QP is drawn perpendicular to OY, then this point P is nothing but the value for n by 2. All right, so this is another way of graphical representation of median by making use of both the types of ogives, that is more than type ogive as well as less than type ogive. So this is all about graphical representation of median. I think it is clear to each one listening to this class. So what we have learned is that median can be calculated with the help of mathematical formula, as well as it can be found out, or its value can be found out from graphs also without calculation. You might be asked sometimes in your exam, find median and verify it graphically. The meaning is that question implies you have to find the value of median using mathematical formula, and then at the same time find the value of median using graphs, and then see that both the values coincide. That means the value obtained graphically and the value obtained through calculation should give you the same result. অর্থাৎ আমি ফর্মুলা ব্যৱহাৰ কৰি যেটো মান পাম মধ্যমাৰ আৰু লেখ ব্যৱহাৰ কৰি আমি যেটো মান পাম দুইটা মান আমি সমান পাব লাগিব। এটো পৰীক্ষাত খুব দৰকাৰী প্ৰশ্ন, এটো পৰীক্ষাত আহি থাকে, you should know how to answer. So now comes the merits and demerits of median. মধ্যমাৰ নো সুবিধা আৰু অসুবিধা কি আছে। এতিয়া প্ৰথম কথা হ'ল আমি সদায় যেতিয়া মেৰিটছ আৰু ডিমেৰিটছ বা সুবিধা অসুবিধাৰ কথা কম যিকোনো মানৰ, আমি সদায় ক্যাৰেক্টাৰিষ্টিক্স বৈশিষ্ট্যকেইটালৈ এবাৰ মনত পেলাম। তাতে যিখিনি বস্তু দিয়া আছিল সেইখিনিৰ লগত আমি ৰিলেট কৰি আমি সেইখিনি বুজি পালাই আমি চাম যে সেই ক্যাৰেক্টাৰিষ্টিক কেইটা আছে নাই। প্ৰথম হ'ল যে ইজি টু আণ্ডাৰষ্টেণ্ড, বুজিবলৈ সহজ হয় নে নহয়। মধ্যমা বুজিবলৈ সহজ, আমি লেখৰ সহায়তো তাক উলিয়াব পাৰো, তাৰ মান উলিয়াব পাৰো। ইট ইজ সিম্পল টু আণ্ডাৰষ্টেণ্ড, ইজি টু ক্যালকুলেট, মান উলিওৱা সহজ, বুজিবলৈ সহজ। লগতে আমাৰ এৰিথমেটিক মিন যেতিয়া আমি পঢ়িছিলো তেতিয়া আমি কি পাইছিলো যে এৰিথমেটিক মিনত আমি ওপেন এন্ড ক্লাसेस, যে প্ৰথমটো যে বিলো 10 ওপৰ লাষ্টৰ ক্লাছটো above something above 90, যেতিয়া ওপেন এন্ড ক্লাसेस থাকে আমাৰ এৰিথমেটিক মিন উলিওৱাত অসুবিধা হৈছিল। কিন্তু মিডিয়ানৰ ক্ষেত্ৰত এই ওপেন এন্ড ক্লাছৰ যেটো প্ৰবলেম সেই প্ৰবলেমটো নাথাকে। আমি ওপেন এন্ড ক্লাছৰ ক্ষেত্ৰত আমি মিডিয়ান ব্যৱহাৰ কৰিব পাৰো। ইয়াৰ উপৰি আৰু এটা greatest advantage of median or merit of median is that without calculation আমি কি কৰিব পাৰো, with the help of graph we can locate median value. আমি লেখৰ সহায়ত median আমি উলিয়াব পাৰো, median বা মধ্যমাৰ মান আমি উলিয়াব পাৰো। তাৰ লগতে আৰু এটা merit বা আৰু এটা সুবিধা medianৰ হ'ল যে কি হয়, আমি তাৰ ডেফিনেশনটো খুব ৰিজিডলি পাওঁ। Formula is very rigidly given to us, and as such what happens, it becomes easy for a common man to understand. Middle most value বুলি ক'লে আমি কিতিয়াবা through inspection খুব বেছি অংক বা ক্যালকুলেশন নকৰাকেও এজন কমন মানে কি কৰিব পাৰিব, এজন যিকোনো লোক এজনে মিডিয়ান মাজৰ ভ্যালুটো কোনটো নিৰূপণ কৰিব পাৰিব by mere inspection also. Tar logot aru eta another advantage of median is that what happens, median is not affected by extreme values. Extreme value ba hekhot thoka dangor ba horu value bahut besi medianor uporot mane probhab na thake. Extreme value undue effect to medianor uporot na thake. Eketa hol ami porha medianor merit. এতিয়া মিডিয়ানৰ কিছুমান ডিমেৰিট আছে আৰু সেই ডিমেৰিট বা অসুবিধাটো, প্ৰথম ডিমেৰিটটো হ'ল যে প্ৰত্যেকটো অবজাৰভেশ্যন আমি ব্যৱহাৰ কৰিবলগীয়া নহয়। মিডিয়ানৰ ক্ষেত্ৰত আমি যেতিয়া পঢ়িছিলোঁ আমি দেখিছিলোঁ যে অকল মিডিয়ান ক্লাছৰ ওচৰৰ পাজৰৰ ভ্যালুবোৰহে ব্যৱহাৰ হৈছিলে, এক্সট্ৰিমিটিজত থকা ভ্যালুবোৰ ব্যৱহাৰ নহয় এটুক আমি এটা অসুবিধা হিচাপে ধৰি লৈছো that is extreme values I mean all the values in the observation do not play a significant role in calculation of median. Only the values lying in the median class, that is lying in the middlemost part, plays a significant role. So representation of the entire series might sometimes not be very well made. So this can be considered as a demerit of median. Apart from this, since median can be located from position, yes, it is sometimes questioned as to why we use so many formula, because we had in yesterday's class we had discussed that median is sometimes in a discrete series. Supposing I had told you that if these are the values x1, x2, etc. up to say x7, x4, x3, x4, x5, x6, okay, there are 6 values and we want to find median. So what happens? The position is somewhere here, but this particular value is nowhere given in the series. We have to calculate the arithmetic mean of the 2 values lying in the middle, and we will get a value over here which will be the median, which actually does not lie in the series. So this is considered to be a demerit of median. So these are some of the merits and demerits of median which are argued upon by people, and as such it is sometimes said that arithmetic mean is a better measure than median, and as such we have discussed in yesterday's class that arithmetic mean is the best, because median sometimes fail to give though it is a good measure, it is an easy measure, sometimes it fails to give a good representation of the entire series. So after this we go to the second positional measure and the third measure which we are learning, that is we learn arithmetic mean. আমি মধ্যৰ বিষয়ে পঢ়িলো, তাৰ পিছত আমি মধ্যমাৰ বিষয়ে পঢ়িলো, আৰু এইবাৰ আমি পঢ়িম regarding mode. Mode is another positional measure, the second positional measure after median. Mode অর্থাৎ বহুলক. Now what is mode? Mode refers to the definition of mode is that value of a distribution which has the highest frequency, all right, so we define mode as that value of a distribution which has the highest frequency, that is that particular value of a distribution which occurs the maximum number of times is known as mode of that particular distribution. অর্থাৎ বহুলক কি, যে এটা গিভেন এটা আমাৰ হাতত যদি অলপ x or value কিছুমান দিয়া আছে, if we have some values of x given to us, all right, it might be height of some students, it might be some marks or any other value represented by the variable x, তেতিয়া mode বা বহুলকে কি বুজাব, যে যিটো ভ্যালু যিটো অবজারভেশন সবতকৈ বেছি বাৰ ইয়াতে আমি দেখা পাম বা যেটো বেসিকে অকার করা বলি আমি কম, that is known as mode বা বহুলক বুলি কোৱা হয়. এতিয়া বহুলকৰ আমি ডিনোট কৰিব কাৰণে আমি বহুলকক আমি কেনেকে লিখো, we write it as mo. Sometimes we write it as mo, or sometimes we use the letter z to represent mode. Symbolically, we use mo or z for depicting mode. All right. Now we shall go to calculation of mode or finding mode in the three different kinds of distributions, that is discrete non-frequency distribution, discrete frequency distribution, and group frequency distribution. So the first case is discrete non-frequency distribution. Discrete non-frequency distribution অর্থাৎ অকল যদি আমাৰ হাতত xৰ কিছুমান ভ্যালু দিয়া আছে x1 x2 etc up to xn কোনো ধৰণৰ ফ্ৰিকুৱেন্সি ইয়াতে মেনশন কৰা নাই তেতিয়া আমি কি ধৰণে মোড উলিয়াম আমি বহুলক কি ধৰণে নিৰ্ণয় কৰিম সো ইয়াতে কোনো ফৰ্মুলা নাই কাৰণ আমি ডেফিনেশনতে গম পাইছো যে frequency to লাগিবই কিমান বার এই প্ৰত্যেকটো ভ্যালু কিমান বার অকার কৰিছে that should be known to us it is not known yes হেতু আমি কি কৰিব লাগিব উলিয়াব লাগিব so for a discrete non frequency distribution by mere inspection only আমি distribution to লৈ চাই আমি তাৰ পৰা যে x1 to নো কেইবাৰ x1 এটা ভ্যালু কিমান বার অকার কৰিছে x2 নো কেইবাৰ অকার কৰিছে xn কেইবাৰ অকার কৰিছে we have to find out and then the value which occurs the maximum number of times supposing x2 is occurring maximum number of times in other words x2 has the highest frequency then mode will be x2 all right so there is no specific formula through mere inspection we can find the value of mode for a discrete non-frequency distribution the second case that is if we are given some discrete values of the variable x along with their respective frequencies yes that is x1 occurs f1 times x2 occurs f2 times x3 occurs f3 times and xn occurs fn times all right in such kind of a distribution mode will be that value which has the highest frequency jitu value karone a frequency to sobot koi dangor hobo hetue hobo the value of mode or the model value ite kitiaba enekwa hobo pare je etait jodi ami jodi okol etaite paisu highest frequency supposing f3 highest value to ahise baki bilakot f3 ke frequency bur sobot ke kom that is f3 is the highest frequency aru nai etai ase if there is only one mode in other words titia hole ki hobo x3 will become the mode will be x3 titia hole ami kom this particular distribution is unimodal if there is only one mode we will call it unimodal if there are two modes je enekwa hoy je f3 to highest frequency ahise aru f10 to highest frequency ahise duita orthat f3 aru f10 homan aru dutate ami orthat dutate highest ase tetiale modor ami duta value pam x3 hobo x10 hobo yes in such a case distribution will be called bimodal ar dutat koi jodi besi variable or karone orthat dutat ke jodi besi mode thake model value thake we will call it a multimodal distribution all right but in our course we shall deal with only unimodal distributions অর্থাৎ যিবোৰ ডিস্ট্ৰিবিউশনত অকল এটা মোড থাকিব হেনেকুৱা ডিস্ট্ৰিবিউশন হে আমি এটো ক্লাছত পঢ়িম now we shall go to the third category that is grouped frequency distribution in case of grouped frequency distribution we shall make use of the following formula for calculation of mode we denote it by z this is equal to L plus Fm minus Fm minus 1 by twice Fm minus Fm minus 1 minus Fm plus 1 into H. Alright, these denotations may be found differently in different books. Implication is same. You can also write it as Z equal to L plus F1 minus F0 by twice F1 minus F0 minus F2 into H. Alright, where Fm and F1 has the same implication, Fm minus 1 and F0 has the same implication, and F2 and Fm plus 1 has the same implication. So now what is this L and all this Fms and Fm minus 1 and Fm plus 1? So L is nothing but the lower limit of the model class. Lower limit of the model class. Alright, Fm or F1, Fm or F1, whatever we call it, it is the frequency of the model class. Frequency of the model class. Alright, Fm minus 1 or F0, it is called the, it is nothing but the frequency of the class, frequency of the class preceding the model class, preceding the model class. Alright, and what is Fm plus 1 or F2? This is the frequency of the class succeeding the model class. Frequency of the class succeeding the model class. Orthat L2 ki, L2 whole model class or lower limit. Fm by F1 is the frequency. Orthat model class or jitu barong barota frequency hetuk ami Fm ba F1 buli koisu. Fm minus 1 by F0 is the frequency of the class preceding the model class. Model class tour agor class interval tour frequency. Aru Fm plus 1 by F2 to whole model class or pisor class interval tour frequency. And what is H? H is nothing but the weight of the model class. Weight of the model class. Alright, just like in case of median class, we had discussed what is weight. Weight of a class is nothing but the difference between the upper limit and the lower limit. Now, in every notation, we are making use of a word. And what is that word? That word is model class. Now, which class is the model class? Yesterday, while talking about median, while discussing median, we were referring to something called the median class, and I had told you how to find a median class. Now, in calculation of mode, we have to find the model class first. Only then we can make use of this formula. The model class has to be defined. In a unimodel distribution, you will have just one model class. And what is that model class? The particular class interval which has the highest frequency will be referred to as the model class. Alright, so if we have a distribution like this given to us, supposing we have been given a grouped frequency distribution like this, alright, where class intervals are given to us and frequencies are given to us. Okay, supposing the frequencies class interval is like this, and so on, supposing, and these are the different frequencies given. Alright, So wherever the highest frequency exists, supposing f2 is the highest frequency amongst all the frequencies given, then this particular class will become the model class. All right. So the first step in calculation of mode for a group frequency distribution will be finding out by observation which will be the model class, and then by making use of the different formula, the formula given to you, by putting the values of the different figures. If this is the model class, f will be this. All right. What will be this? This is the frequency of the class preceding the model class. This becomes your fm minus 1. This is fm, and this is fm plus 1. Or if you make use of the other notations, this is nothing but f1, this is f0, and this is f2. All right. In this way, we will find the difference between the upper limit and the lower limit will give us the width h. All right. And what will be L? If this is the model class, then L will be 10. Okay. So the lower limit of the model class is L. All right. Again, just like median, you know that mode is also a measure of position, a positional measure. That is, with the help of graph, লেখৰ সহায়ত আমি কি কৰিব পাৰো? বহুলক নিৰ্ণয় কৰিব পাৰো। আৰু মিডিয়ানৰ ক্ষেত্ৰত আমি কি ব্যৱহাৰ কৰিছিলো? অগিভ ব্যৱহাৰ কৰি আমি মিডিয়ান নিৰূপণ কৰিছিলো, মধ্যমা নিৰূপণ কৰিছিলো। আৰু আমি এতিয়া বহুলক নিৰূপণ কৰিবৰ বাবে আমি যেতিয়া গ্ৰাফ ব্যৱহাৰ কৰিম, তেতিয়া হলে আমি হিস্টোগ্ৰামৰ ব্যৱহাৰ কৰিম। হিস্টোগ্ৰামৰ সহায়ত আমি মোড উলিয়াম। গ্ৰাফিক্যাল ৰিপ্ৰেজেন্টেশন অফ মোড। কি দৰে আমি লেখৰ সহায়তনো বহুলক নিৰ্ণয় কৰিব পাৰো তাকে চাম। So as you know from your earlier class, HS first year class, that to draw a histogram, we have to have on the x-axis the class intervals, which are continuous obviously, and on the y-axis we have the frequencies f. All right. আৰু যেতিয়া আমি যিকোনো ডেটাৰ পৰা আমি হিস্টোগ্ৰাম আঁকিম, it will look somewhat like this. Supposing our histogram looks like this. All right. And now we know to draw a histogram. Now the problem here is how to calculate mode. All right. So can we imagine where mode will lie? See, the highest column here represents the class interval with highest frequency up to this point. So this is our model class. So in between this class, at this area, mode will lie. What we do is, from the upper point of the preceding column of the histogram, we will draw a line to the vertex, opposite vertex of the tallest column. From the succeeding column of the histogram, the succeeding column of the tallest column, from this point we will draw a line to the opposite vertex of the tallest column, and these two lines will meet at a point. Supposing this is point P. All right. From point P we will drop a perpendicular to the x-axis. Supposing this is point Z. All right. PZ perpendicular to OX is drawn. This Z lies on the X coordinate. Z lies here on the X axis. All right? And since it lies on the X axis, the Y coordinate will be 0 and it will have a X coordinate. The X coordinate of Z is the required median. Is the required mode of the given distribution. A particular distribution to karne a Z or Z to X coordinate hobo hetwe hol modor ba bahulokor man. So this is how we calculate mode from a graph with the help of histogram. So you should remember for 1 mark question also, which graph is used for representation of mode? It is histogram. And which graph is used for determination of median? It is the Ogive. Now comes the use or the merits and demerits of mode. The first merit of mode, just like arithmetic and median, it is simple to understand and it is easy to calculate. This is the very basic merit of mode. The third point of merit ba modor bahulokor subidha hol je open end classes or karane, unlike arithmetic mean, mode can be used in case of open end class intervals also. All right, this is the third or the another very important merit of mode. Another point of advantage or merit of mode is that it can be located graphically. যে আমি এইমাত্ৰ পঢ়িলোঁ যে ক্যালকুলেশন নকৰাকেও আমি লেখৰ সহায়ত আমি বহুলক নিৰূপণ কৰিবলৈ পাৰোঁ. These are the merits. But mode has some demerits also. The first demerit of mode is that it is not rigidly defined. Definition of mode is not rigid. Eta distribution jodi unimodal nohoy, আমি already কৈছো what is unimodal, bimodal and multimodal. Unimodal nohoy palai jodi bimodal ba multimodal hoy titiahole eta distribution not mode to ill defined hobo, orthat it will not be rigidly defined. The definition will not be very specific. Next point is that it cannot be put into further algebraic treatment. The value of mode cannot be put for further algebraic treatment. Unlike arithmetic mean, mode gets affected by sampling fluctuation to a greater extent than arithmetic mean. So this can also be regarded as a demerit or a disadvantage of mode. So these are some of the merits and demerits of mode. Now we have to learn about another very important relationship between arithmetic mean, median and mode, which is known as the empirical relationship between mean, median and mode. Empirical relationship between arithmetic mean, median and mode. But before going to the empirical relationship, directly in fact going into it, before going to it, we shall brush up little bit about symmetrical and asymmetrical distribution. So let us take up some figures. Okay. All right, I have drawn frequency curves of 3 different shapes. All right. So here you see, this is the bell-shaped curve, or this is the curve for a symmetrical distribution. This is called a symmetrical distribution. If you have a curve of this shape, you will call this particular distribution to be symmetrical. All right. For a symmetrical distribution, what happens? Mean, median and mode coincide. They lie at the same point. Tar mane ki the arithmetic mean, median aru mode tinta eta point ote hoy orthat tinta saman. In case you have curves of this shape which has a tail either towards the right hand side or towards the left hand side. If you have a tail towards the right or towards the left, we will call such distribution to be skewed distribution or asymmetrical distribution. In case of skewed or asymmetrical distribution, this relation will not hold. And what we are going to learn here is the empirical relationship for such kind of distributions. All right, that is for a moderately asymmetrical or skewed distribution. What will be the relationship between mean, median and mode? Here if you see, this is the mode, then you have median, and here you have arithmetic mean. This is a positively skewed distribution curve of a positively skewed distribution. This is a negatively skewed distribution in which here is the value for mode, here you have median, and here you will have the arithmetic mean. All right. So here the relationship between them is x bar is the highest, then you have median, and then you have mode. This is the value for x bar, this is median, and this is mode. So mode has the least value, and in the other case x bar is the least value. All right, and then you have median, and then you have mode. Okay, so now what the empirical relationship between mean, median and mode says? It says that for a asymmetrical or skewed distribution, the following mathematical relation or empirical relationship exists between mean, median and mode. And what is it? Mean minus mode is equal to thrice mean minus median. Symbolically, if you write, you can write it as x bar minus z is equal to thrice x bar minus median. All right. So if you know any two of the measures, say either mean and mode, you can find out median. If you know median and mean, you can find mode. If you know median and mode, then also you can find arithmetic mean for any asymmetric, and this holds for skewed distribution. And I have already told you that is for a symmetrical distribution. In case of a symmetrical distribution, the relationship is x bar is equal to median is equal to mode. This is for a symmetrical distribution. All right. So please try to remember this formula because it will be used while doing sums later on. So we will take up some sums, mathematical problems on arithmetic mean, median and mode. All right. So let us write down the questions. Question number 1, calculate AM, median and mode for the following data. For the following data. 5, 9, 15, 25, 17, 19, 15, 6. Number B, 7, 8, 17, 5, 21, 36, 42, 27 and 38. While calculating or while doing sums, we should always remember that first we have to look into the sum and understand what kind of a series is given to us. So both these series are discrete non-frequency distribution. Discrete non-frequency distribution. All right. So for finding arithmetic mean in such kind of a distribution, what was the formula? Arithmetic mean is equal to x bar is equal to 1 by n summation x. Yes, for a discrete series, if you do not make the table, that is fine. So what will you do is, you will find, suppose this is number A. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8. So here n is equal to 8. And for summation x, what we have to do? We have to add all these values. That is, x bar will be equal to 1 by 8 and you will add up all the values given to you. This is very, very, very simple. All the values up to 6. Whatever you get will be the result for arithmetic mean. For finding mode, in case of discrete non-frequency distribution, what we do? We do it by mere inspection. So we shall write down for calculation of mode. For calculation of mode, we shall do it by inspection. All right. So you will look into the series and you see how many times each of the values are occurring. 5 is occurring only one time. 9 is occurring one time. 15 occurs 2 times. 25 is occurring one time. 17 is occurring one time. 19 occurs one time. 6 also occurs one time. That is, there is only one value which is occurring twice. So what will be our mode? Mode will be equal to 15 because it has the highest number of occurrences. All right. Similarly, if you look into the next data, you see 7, 8, 17, 5, 21, 36, 42, 27, 38. all are different numbers. None of the number is repeated, that is, they are all occurring one time. So here mode is not defined. For number B, Z is not defined, or you may write mode is ill-defined. There is no mode for this series. So this is the series given to us. We shall write arranging the data. This is calculation of median now. All right, arranging the data in order of magnitude, we have 5, then comes 6, then comes 9, then 15, then 17, then we have 19. 15 occurs twice, so we will write it twice. 15, then 17, 19, and 25. I think we have written all the numbers. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have arranged the numbers, and that is the first step. In second step, we will write n is equal to 8, which is even. All right. So if we have even number of observations, what is the formula for finding median? Median will be equal to, yes, what was the formula? Arithmetic mean of n by 2th and n by 2 plus 1th observations. All right, that means we have to find the arithmetic mean of n. Here is 8, 8 by 2 is 4th, and 4th plus n by 2 is 4 plus 1, 5th. 4th plus 5th observations, arithmetic mean will give us the value for median. Now which is the 4th observation? 1, 2, 3, 4. This is the 4th observation. This is the 5th observation. So what will be the value for median? Median is equal to 15 plus 15 divided by 2. That is 15 will be the median for the given series. Okay. Now if you have an observation like this, let us take the same observation, but we remove one of the values. Let us take 115 only, so that you have odd number of observations. Then it will be easier for us to see now what we do in case we have odd number of observations. Again, we shall first arrange the data in order of magnitude. 5, 6, 9, 15, 17, 19 and 25. So we have arranged the data in order of magnitude. So how many values are there? N is equal to 7, which is odd. All right. So this is our first step, but we should write arranging the data in order of magnitude. This is important. Arranging the data in order of magnitude. Please write this. All right. Okay, now we have arranged the data. We have also found out the number of observations, and we have found it to be odd. When it is odd, median is equal to value of n plus 1 by 2th observation. So what is n here? N is 7 plus 1 is 8. 8 by 2 is 4. So value of fourth observation. So what is our fourth observation? 1, 2, 3, 4. So our fourth observation here, the value of the fourth observation is 15. So median will be 15. This is how you calculate arithmetic mean, median and mode for a discrete non-frequency distribution. Alright. Now we shall take up the case when you have a discrete frequency distribution given to you. Supposing you have a distribution like this, where x and f are given to you. X and f are given. X's are 10, 20, 30, 40, 50. Alright? And the frequencies given are 2, 4, 13, 7, 9. Alright? So mode will be the easiest, so let us do mode first. Here, so if while calculating mode, you see, first of all, we have to look into the frequency column. Alright? In the frequency column, which is the highest frequency? Highest frequency is 13. Here, highest frequency is equal to 13, corresponding to x equal to 30. Yes, corresponding to x equal to 30. Therefore, required mode will be 13, not 30, 1, 3. So required mode is corresponding, it's okay. Required mode is 33, 0. So this is our value for mode. Alright, so mode is very simple. Now for calculating arithmetic mean and median, we shall proceed as follows. Let us go to calculation of arithmetic mean first. So we shall calculate mean. So you remember how to find arithmetic mean, what is the formula? We shall first use the direct method, okay? So this is 1 by n summation fx. Alright, and for calculating median, there is no specific formula, but I think you remember we have to construct the cumulative frequency distribution table. So we will make the table. Together we can do median and mode, median and arithmetic mean calculation. So the table will look like this. First column is for x, the second column is for f, the third column will be fx, and then we will also find the cumulative frequencies. What you do is, you will find n here, you will find summation fx over here, alright, you will find the cumulative frequencies, this will be equal to n. You please try to complete this table at home so that we can discuss it in the next class. So with this, we come to the end of today's classroom, and we hope to do some more classes in the next class, where we shall take up some sums from group frequency distribution, and we shall also try to apply the assume mean method, because this is the formula for direct method. We shall make use of the assume mean method as well as the step deviation method for calculation of arithmetic mean. Stay happy, stay blessed, and stay safe. Thank you for today.